Hello students, Namaste parents and educators. Today we are going to continue our discussion with mass of atom and its calculation and discussion related to mass of atom. Alright, we had already calculated mass of some atoms like H11 protium, N147 in our earlier videos. Alright, so let us start with the value of AMU. AMU denotes atomic mass unit. It can also be written as 1U, one unified mass. All right, AMU or U can be written. All right, okay. AMU was defined as exactly the mass which came out as 1/12 part of mass of one atom of C12 isotope. All right, it is the most abundant isotope of carbon. A careful measurement was done. It came out to be, value came out to be 1.6605 into 10 power minus 24 gram. All right, okay. And one interesting thing is there, we had already calculated mass of H11 atom, protium atom, using subatomic particles, right? Using subatomic particles, we have already done this calculation in earlier video, all right? And it came out as 1.67 into 10 power minus 24 gram, all right? Because what subatomic particles does H11 atom have? H11 had one proton and one electron. It has zero neutron, all right? Zero neutron. Neutrons are not present in what H11 atom, all right? Okay. So, and we had already discussed in that video, mass of electron is very less with respect to mass of proton. So during calculation, mass of electron can be neglected. All right. So what overall value we got it as mass of one proton, whatever the mass of one proton was there, that overall came out to be mass of our one protium atom. All right. Now, in terms of AMU, you can also say in terms of AMU, we use the value as 1 AMU. All right, 1 AMU. Interestingly, the value of 1 AMU, if you write it here, 1 AMU, it will have 1.66 into 10 to the power minus 24 gram. If you approximate the value to two decimal places, it will come out as 1.66 into 10 power minus 24 gram. All right. So it is clear now there is slight difference in these two values. It is 1.66 into 10 power minus 24. It is 1.67 into 10 power minus 24. And both mass is related to the same thing. How can this happen? All right. The question is this. All right. Okay. So now these both values, they are trying to relate about the same thing. And if you want to check about the, okay, what is the mass of hydrogen atom mainly? So it is mass of one proton. All right. Okay. So now let us check mass of proton in terms of AMU. All right, because mass of proton in terms of gram, it is 1.67 into 10 power minus 24 gram. So one important thing which we come to know now, that there is a slight difference in mass if we come to know about it, if we take it in terms of AMU and if we calculate it using subatomic particles. All right, there are two different values. There is a slight difference, but these are two different values. All right, what does it indicate? What does it denote? This is our main discussion. All right, okay. So let us first discuss about mass of proton in terms of gram. We know it is 1.67, and the next digit, which almost if you approximate it, it will come out to be 1.673 into 10 power minus 24 grams. All right. Okay. So now let us check the value of mass of proton in terms of AMU. All right. Okay. So if we calculate mass of proton in terms of AMU, for 1 gram, we can write it as 1 AMU. It is equal to 1.66 into 10 power minus 24 gram. All right. So for 1 gram, we can write it as 1 upon 1.66 into 10 power minus 24 AMU. All right. The same thing, same factor we have used it here. All right. And if you calculate this value, it will approximately come out as 1.007 AMU. All right. So mass of proton is 1.007 AMU. Mass of proton is slightly greater than 1 AMU. All right. Similarly, if you calculate about mass of neutron is slightly heavier with respect to mass of proton. If we come in calculation of mass of atom, so now this slight difference in mass of proton, mass of electron will also play a significant role to some extent. All right. So we are discussing in terms of AMU. All right. Okay. So now let us check about value of mass of electron and mass of neutron in terms of AMU. All right. So let us check about the data again. We had already shared a data of mass of subatomic particles and charge of subatomic particles in earlier video, in which some approximation we had also done. But now since we are checking about mass of a particular atom, so now let us come to the precise value. So for electron, if we take mass in grams and if we try to put it in 10 power minus 24 terms, so mass of electron will come out to be 0.00091 multiplied by 10 power minus 24 grams. Mass of proton 1.67262. All right. So if you want to approximate it, it will come out as 3, right? 1.673. If we try to approximate it, and so the value, if we round it off, so value will be 1.675, right? Okay. So 1.67262 into 10 power minus 24, 1.67493 into 10 power minus 24. All right. So now in terms of AMU, mass of electron will come out as 0.00055. Mass of proton 1.00727. Mass of neutron will come out to be 1.00866. All right. This value is in AMU. All right. So now if you want to calculate mass of any atom, which you have already calculated in terms of gram, now if you want to calculate it using the subatomic particles and if you take it in AMU unit, you will come to the conclusion that mass of that particular atom, it is not exactly, for example, mass of N146 in AMU, the mass which we take is 14 AMU, right? But when you calculate it using the subatomic particles, now the mass will be slightly greater than 14 AMU. All right, you can check it using any atom. All right. So what the conclusion for today's lecture is, mass of atom, when you calculate, you can check about any particular atom. All right. When you take that particular isotope and when you calculate the mass using subatomic particles, it will always come a little bit more, slightly, it will always be slightly greater than mass of actual atom, which we take in AMU. All right. So this is the main conclusion part. Now the thing is, where does this mass go? Why is there this difference? This difference in mass, there will be a slight difference in mass. All right. Let us say that slight difference as delta M. Delta M is denoted as mass defect. It is an important point related to nuclear chemistry part. Einstein's famous equation E equals mc square is related here. All right. Stability of nucleus, binding energy, all these things are related with the term of mass defect. All right, which we will discuss completely in the nuclear chemistry part. If you have any confusion or doubt related to this, you can write separately in email to me. You can write your question, you can send your query, all right, on indioneducation@gmail.com. You will get answer to your question. All right. Okay. Thank you so much. Please like and share and subscribe the video. Thank you.